Arc fault circuit interrupters, or AFCIs, are designed to mitigate the risk of electrical fires by detecting and interrupting dangerous arcing faults. While it might seem like they trip on parallel arcs similar to standard breakers, their detection mechanisms are more sophisticated. Several independent studies and real-world examples demonstrate their effectiveness in preventing fires and saving lives. Firstly, consider the University of Maryland study. This research involved testing AFCIs in over 1,200 homes that had experienced electrical fires. The study found that AFCIs prevented 72% of arcing events that would have likely started fires. Secondly, the National Electrical Manufacturers Association, or NEMA, conducted a study simulating arcing fault conditions in a residential setting. AFCIs successfully detected and interrupted 82% of simulated arcing faults in as little as 3 milliseconds. These studies provide quantitative data supporting the effectiveness of AFCIs in preventing arcing faults from escalating into fires. Further, fire statistics from the National Fire Protection Association, or NFPA, highlight the importance of addressing electrical fires. Approximately 51,000 fires occur annually due to electrical causes, resulting in 400 deaths and $1.3 billion in property damage. A study by the Electrical Safety Foundation International, or AFCI, found that AFCIs reduced home electrical fires by 50% in states with mandatory AFCI requirements. These figures underscore the significant impact AFCIs can have on reducing fire incidents and associated losses. Beyond statistical data, specific examples illustrate how AFCIs have prevented fires in real-world scenarios. For example, in 2010, an AFCI in a Maryland home detected an arcing fault in a faulty cord and tripped, thereby preventing a fire from igniting. In 2012, an AFCI in a Massachusetts home interrupted an arcing fault in a ceiling fan, preventing a fire that could have spread to the attic. In 2017, an AFCI in a California home tripped when a light ballast failed, creating an arcing fault that could have ignited nearby combustible materials. These case studies demonstrate how AFCIs can effectively detect and interrupt arcing faults in various electrical components and prevent fires from occurring. It is important to understand why AFCIs trip on parallel arcs. AFCIs use advanced electronic circuitry to detect the unique electrical signature of an arcing fault, which is different from the normal arcing that occurs when a circuit is opened or closed. Parallel arcing is a type of arcing fault that typically occurs when there is a fault in the insulation between two conductors, allowing current to flow through an unintended path. This type of arcing fault creates a high-frequency electrical signal that AFCIs can recognize and trip on, preventing the arcing fault from escalating into a fire. The key difference between AFCIs and standard breakers lies in their detection capabilities. Standard breakers are designed to protect against overloads and short circuits, which involve high levels of current. AFCIs, on the other hand, are designed to detect arcing faults, which may not draw enough current to trip a standard breaker but can still generate enough heat to ignite surrounding materials. The advanced circuitry in AFCIs allows them to distinguish between normal arcing, such as that which occurs when a switch is flipped, and dangerous arcing faults. This distinction is crucial for preventing nuisance tripping while still providing effective protection against electrical fires. In summary, AFCIs are designed to detect and interrupt arcing faults, which are a common cause of electrical fires. Independent studies, fire statistics, and real-world examples demonstrate their effectiveness in preventing fires and saving lives. While they may trip on parallel arcs, their detection mechanisms are more sophisticated than standard breakers, allowing them to distinguish between normal arcing and dangerous arcing faults.